All right, today we're going to be looking at Unit 4.3, Operations with Polynomials. And today we're going to start with adding and subtracting polynomials. Now we need to remember that a polynomial is a monomial, or the sum of two monomials, or more monomials. A binomial, that is a very important word there, binomial, is the sum of two monomials, and a trinomial is the sum of three monomials. The degree of a monomial is the greatest degree of any term in the polynomial. Polynomials can be added or subtracted by performing the operations indicated and combining the like terms. So you can subtract a polynomial by adding its additive inverse. So it's important when we subtract, we're actually not going to subtract, we're going to add its additive inverse. The sum or difference of polynomials will have the same variables and exponents as the original polynomials. So if we start off with x squareds and x to the first and constants, we're going to end with the same types of terms. But we'll probably have different coefficients. So the sum or difference of two polynomials is also a polynomial. So the first thing we're going to do is identify polynomials. So we're going to say whether each expression is a polynomial, and if it is a polynomial, we're going to state the degree of the polynomial. So if we look at statement A here, A is not a polynomial because we have the cube root of x. And the cube root of x, so let me write this out here. The cube root of x is the same thing as x to the 1/3 power. And one thing with polynomials, there is a limit as to what powers we can have on our variables. And we cannot have imaginary powers. We cannot have fractional powers like we do here with x to 1/3, and we cannot have negative powers. So that is not a polynomial. B, if you look at B, you have 5a to the 4th b plus 3a squared b to the 7th minus 9. Well, to find that is a polynomial. There's no powers that are outlawed, so that is a polynomial. It's a polynomial with two variables. To find the degree of a polynomial, it's going to be the highest term degree. So we look at the degrees of each monomial. If you look at the degree of 5a to the 4th b, you're going to add the powers together of the two variables. So this is going to be 4 plus 1. So the degree of this would be 5. The degree of this one would be 2 plus 7, so that would be 9. So the degree of this polynomial is 9. All right, and then the C, we have 2/3 x to the negative 5th minus 6 x to the negative 3 minus x. That is not a polynomial. If we were to write this without the negative exponents, it would look like this. Negative x over 2/3 x to the 5th minus 6x to the 3rd. And that is not a polynomial. That is a rational expression. All right. So, moving on. State the degree of each polynomial. So, these are all polynomials, A through D. The degree is going to be the highest power if it is just one variable. So in this case, the degree is 7 for letter A. For letter B, we have two variables here, so we're going to add those together. So 7 plus 2 again is 9. 1 plus 1 is 2. So our degree here is 9. C, p to the 10th. So the degree is 10. And then D, there's no exponent and there's no variable. So with there being no variable, our degree is 0. All right. So now, when we add polynomials, there's two ways to do it. We can add horizontally or we can add vertically. When we add horizontally, we're going to group together the things that match up. So 6x cubed and x cubed. So like terms we're going to group up together. And then we put a plus sign to separate them, and then we move on to x squareds now. So 7x squared minus 4x squared. Plus, then we move on to the x to the first. So negative 2x minus 8x. Plus, and then we have 5 plus 1. So we've grouped together all of the like terms, and then we just add them together. So that is 7x cubed plus 3x squared minus 10x plus 6. So that's one way to do it. The other way to do it is to add vertically. So just like we learned back in elementary school, we can actually stack these things on top of each other. And just add them together. So 6x cubed plus x cubed is 7x cubed. 7x squared minus 4x squared is 3x squared. Negative 2x minus 8x is minus 10x. And then 5 plus 1 is 6. So we end up in the same place, just different ways of getting there. So another example here, I'm just going to do a horizontal addition for right now, but you could do vertical for this one as well. So 2x cubed plus 4x cubed. And then we got 9x squared minus 7x squared. Then we've got 6x plus 5x. Then we've got minus 3. That's not going to be added to anything, so we can just leave it as minus 3. So 2x cubed plus 4x cubed is 6x cubed. Then we've got 2x squared, and we've got 11x minus 3, and that's our final answer. All right, so that's adding polynomials. So we can also subtract polynomials the exact same way, except remember when we subtract, we're not going to subtract, we're going to add the additive inverse. So we're still going to group things together by degree. So this first one, there's only one 2x to the fifth term, and it's in the first one, so we're just going to leave that as is. Then we move to the fourths. So we got 11x to the fourth, and then we're going to add the additive inverse of the x to the fourth term in the second. It's a 5x to the fourth, so we're going to add a negative 5x to the fourth. There's no x to the third term in the first polynomial, so we are going to use a placeholder, 0x to the third plus negative 9x to the third. Then we have no x squared term in either one, so we can skip that altogether and go to 7x. And then the additive inverse of negative 3x is positive 3x. And then we have negative 8, and then it's going to be plus negative 4. All right, so in simplifying this, we got 2x to the fifth. 11x to the fourth minus or plus negative 5x to the fourth is 6x to the fourth. Then I've got 0x to the third plus negative 9x to the third. So that's going to be minus 9x to the third. I got 7x plus 3x, so that's plus 10x. And then I've got negative 8 plus negative 4, so that's minus 12. So that is our final answer there. 2x to the fifth plus 6x to the fourth minus 9x third plus 10x minus 12. So just like with addition, we can do subtraction horizontally and vertically. So I'll show you how to do vertical subtraction here. So write the first one, 8x squared minus 3x plus 2. Underneath it, I'm going to write the second polynomial, 5x cubed. And we're going to do the additive inverse of each of these. So minus 2x squared plus 6x plus 9. Now, you'll notice that the top one does not have a x to the third term, and the bottom one does. So we need to put a 0x to the third there, just as a placeholder. So that way we don't forget. All right, so now we can do our subtraction. So 0x to the third minus 5x to the third is negative 5x to the third. 8x squared minus 2x squared is 6x squared. Negative 3x plus 6x is plus 3x. And then 2 plus 9 is plus 11. So that gets us through adding and subtracting. Now, multiplying, you've actually done this before several times. You've done it this year. You've done it in past years. Polynomials can be multiplied First off, by using the distributive property to multiply each term in one polynomial by each term in the other. When polynomials are multiplied, the product is also a polynomial. This is similar to the system of integers, which is also closed under multiplication. So, to multiply two binomials, you can use a shortcut called the FOIL method. So, that's whenever you have two binomials. But whenever we have a monomial multiplied by a polynomial, we just distribute the monomial to everything inside the parentheses. So this is the same thing as 2x times 4x cubed plus 2x times 5x squared plus 2x times negative x plus 2x times negative 7. So this becomes 8x to the fourth plus 10x to the third plus, sorry, that should be now not plus, but minus, because it's going to be negative 2x squared, and then minus 14x. And that is how we distribute that monomial to everything inside the parentheses. Now, when we multiply binomials, we are going to use the FOIL method. So on the example that they give you that's labeled with the FOIL outline, they do the 2x times the x, that's the f, the first terms. Then the 2x times the negative 3, that's the product of the outer terms. Then you do 4 times x, that's the product of the inner terms. And then you do 4 times negative 3, and that's the product of the last term, so FOIL. You end up 2x squared minus 6x plus 4x minus 12, and you can combine those like terms there in the middle to negative 6x plus 4x to get negative 2x. All right, so we're going to do that here. We're going to multiply binomials, and you can do any order that you want. You could multiply the first two together. You could multiply the last two together. If you're really crazy, you could multiply the outer two together. It does not matter. We're going to do, for right now, I'm just going to do the last two. It does not matter the order, though, for real. You'll end up in the same place. But we're going to do a times 4a plus a times 1 plus negative 7 times 4a plus negative 7 times 1. So this is still 3a plus 5. A times 4a is 4a squared. A times 1 is a. Negative 7 times 4a is negative 28a. And then negative 7 times 1 is negative 7. We can combine these like terms here in the middle. So we're left with 3a plus 5 and 4a squared minus 27a minus 7. All right, so now what we're going to do is we're going to multiply everything in the first term with everything in the second term. We cannot FOIL because the second term is now not a binomial, it's a trinomial. So the way we're going to multiply this is 3a times 4a squared plus 3a times negative 27a plus 3a times negative 7 plus 5 times 4a squared plus 5 times negative 27a plus 5 times negative 7. All right, so when we do that multiplication, I have to move over here to give us some space. We get 12a cubed, and then I get 3a times negative 27a, that's negative 81a squared. 3a times negative 7 is negative 21a. 5 times 4a is 20a squared. And then we have 5 times negative 27a, that's negative 135a. And then 5 times negative 7 is negative 35. So 12a cubed, I got some like terms. I got the negative 81a squared and the positive 20a squared. So put those together to make negative 61a squared. And then I got some more like terms. I got the negative 21a and the negative 135a. So put those together and make negative 156a, and then minus 35, and that's our final answer. All right. So I'm going to show you a little quicker way than writing this whole thing out like we did here. I want to show you a quicker way. So we're going to do this again. So this time I'm going to multiply the first two together. Like I said, it does not matter the order. So we're going to FOIL negative 2r times 5r is negative 10r squared. Negative 2r times negative 1 is positive 2r. Negative 3 times 5r is negative 15r. And then negative 3 times negative 1 is positive 3. And we still have the r plus 4 hanging out there. All right, so now what we're going to do is we are going to combine our like terms, the 2r and the negative 15r. So that becomes negative 10r squared minus 13r plus 3. And then we have r plus 4. Now, to save us some time and some room, I'm going to actually use a different tool that I call the grid method. Some people call it the box method. But we're just going to write our trinomial across the top of this box, and then the binomial down the side, like so. And we're going to fill each box here. So we're going to multiply r with negative 10r squared to get negative 10r cubed. Then I multiply r with the negative 13r to get negative 13r squared. Then r with 3 to get 3r. Then I multiply 4 by the negative 10r squared to get negative 40r squared. 4 times negative 13 is going to be negative 52r. And then 4 times 3 is 12. So now I can combine my like terms. Well, there's only one r cubed term, so that's going to be negative 10r cubed. Then I can combine my r squared terms. So that's going to be negative 53r squared. Then I can combine my r terms. So that's negative 52 plus 3r, so that's going to be negative 49r. And then I have a constant of 12. All right, so that is how you multiply three binomials together. It's going to be a step-by-step process. You can use either method. You can write it all out horizontally, or you can use the box and grid, whatever you want to call it. I don't think there's a problem with either one. I think the grid is a little quicker, a little easier. Those of you taking the ACT, it might save you some time, but both are effective. All right, so now we are going to apply what we've learned, combine both. So Byron's baking a 3-tier cake for a birthday party. Each tier will have half the volume of the previous tier. The dimensions of the first tier are shown, and we're asked to find the total volume of the cake. Well, first thing we need to do is find the volume of the bottom layer, and remember that volume is equal to length times width times height. So, to find the volume of tier 1, it's going to be x times 4x minus 3 times 2x plus 1. So, when I am wanting to multiply this, I'm going to distribute the x to the 4x minus 3 to make that 4x squared minus 3x. And now I can FOIL. 4x squared times 2x is 8x cubed. 4x squared times 1 is 4x squared. Negative 3x times 2x is negative 6x squared. And then negative 3x times 1 is negative 3x. combine like terms here in the middle. I get 8x cubed minus 2x squared minus 3x. So that gives me the volume of tier 1. Well, so that is, I'm going to label that tier 1. To find the volume of tier 2, it's going to be half of that. So tier 2 is 1/2 of 8x cubed minus 2x squared minus 3x. So half of 8x cubed is 4x cubed. Half of negative 2x is negative 1x squared. Half of negative 3x is negative 3 over 2x. So that gets me the volume of tier 2. Now to find the volume of tier 3, I take half of that. Half of 4x cubed minus x squared minus 3/2 x. I also could have taken 1/4 of the volume of tier 1, but either way it works. So half of tier 2 would be 2x cubed minus 1/2 x squared minus 3/4 x. So now what I'm going to do to find the volume of the entire cake is I need to take tier 1's volume and add it to tier 2 volumes and tier 3's volume. So I have 8x cubed plus 4x cubed plus 2x cubed. So that is 14x cubed. And I have negative 2x squared, negative 1x squared, and negative 1/2 x squared. So that's negative 7/2 x squared. And then I have negative 3x, negative 3/2 x, and negative 3/4 x. So if everything was over 4, that would be negative 6/4, and that would be negative 12. So 12 plus 6 is 18, plus 3 is 21. So negative 21/4 x. And that is the entire volume. All right. So we're not going to worry about the practice problems. I would encourage you to do those on your own to get some extra practice. Those should be pretty simple and straightforward considering what we've covered so far today. But if you have any questions outside of that, please shoot me an email or a Canvas message, and I will get back to you as soon as I can.